Very warm welcome to everybody who has logged in to this second of two Paths webinars. The first one, the materials are already available, and therefore I do not propose to go through any of the material I talked about last time. A request just to remind you please to keep your phones muted so that we do not get any sound leakage to spoil the feedback sound that you will hear. In the next half hour or so, I intend to talk through about 5 small demonstration models showing various aspects of paths and pseudo-paths. And I will finish off doing a quick look at some paths in virtual reality in Witness 14. Okay, the first model I have opened is a model that we did see something of last time around, and it is using paths. And in the previous example I showed the way we use the walk time function to allow the time along the path to vary depending upon the length of the path, which can be very convenient, especially if you're stretching your paths to lay them out on top of a CAD background. However, there are times when it is safer for us to set the travel time along paths explicitly, either in Witness itself or more likely from Excel. So in the case in point, I have my path W3, and if I double click onto it, I can see that my path traverse time, rather than using the walk time function, uses a variable VR M1 to M2 TT, standing for travel time. And I set that information, in this case in Model Initialize Actions, to 5 time units. Normally this would be a value read in from Excel for maximum flexibility. On the path I have got actions on entry, where I record the time when the part arrives on the path, and at the end of the path I record the time now minus the time when the part arrived to give me the travel time along the path. So this is an independent verification that the values I've put in are being used correctly, and it's always useful when testing your models to have some form of independent checking to make sure it's doing what you believe it should do. So if I set my model running, I can see my labour walking along the path, and I can see the travel time as set in Model Initialize Actions is 5 minutes. Here's a time when the labour and parts commence on the path journey, and this is a time being updated every time our labour and parts leave the path. So in this case I can extend my path length and I can continue running, and I still have the same travel time. Okay, very simple but very convenient, and certainly with quite a few models I do, I choose to have the travel time set explicitly from data in Excel, particularly if I'm trying to establish the takt time for operators moving around a small cell of machines. Second model I'm going to show you is to do with changing variable speed along paths. So if I open that model, I will not save the previous one. And in this model I have a path which has called walkway, and the travel time along the path is using a witness function, one I've created myself. Many of you will be familiar with the built-in functions in Witness, but hopefully the more experienced of you will have been able to create and use your own private functions. If I look at my path, again I'm doing my checking so that when the part arrives on the path I write the time, in this case to an attribute on the part, and when I leave the path I check the time and print it out on a displayed variable so I can see how long the part took travelling along the path. If I set my model running, I have 2 part types going along here. One which is effectively moving empty a lot quicker than one that is moving full. And you can see, looking at the variable to the top right, the time along the path varies between 7 and 18 time units depending on the part type going along. If I take a look in the function, it is quite a simple function. It looks at another attribute, which in this case is a string attribute, which is set against the part. I set that in actions on create of the part, or potentially I could set it at the beginning of the operation in a machine or a buffer, etc. So in this case, the path interrogates the part as it arrives, and if the attribute is full, it gives it a fixed cycle time of 18 time units, and if it's empty, it uses a quicker travel time of 7 units. These values are hard-coded here just for simplicity, but you can imagine them being read from a variable array if you have a lot of data that you're entering through Excel. Okay, let me close that down. If I look at my part very quickly, double click on it, on here I am simply randomly sampling every time I create a part to determine whether it's going to be a loaded, a full or empty part, and I change the pen colour accordingly so that we have a red and a green part in our model, which always aids visual inspection and understanding. Okay, so very simple again, but it just shows that we can manipulate our times in a way that we choose fit, simply by using a function. So that is for a path, explicit path element. I can do something quite similar on pseudo-paths. So I shall open another model, which is pseudo-path, variable speed along pseudo-paths. In this case I have 2 parts, and let me just set the model running, and we can see that we have red parts leaving machine 1, which are moving quickly, and we have green parts leaving machine 2, which are moving rather more slowly. And we can see my check time, just as I've done in the other models, is being, I'm time stamping my parts as they join the path, and I'm checking the elapsed time as they leave the path and arriving machine 3, and we can see the times are 8 minutes, or 8 time units for our faster moving red parts, and 32 time units for our slower moving green parts. This information is set not on the path, because of course we don't have an explicit path, but in model options paths. Actions on entry to the path, I timestamp onto a real attribute. AR stands for attribute real, which is a naming convention we tend to use to improve clarity in our models. And in actions on leave, I display in a variable, a real variable, the time now minus the time when a part joined the path to give me my handshake back. The travel time is a function, as we saw before, function travel time. So let's have a look in there. And in this case, I'm simply taking the walk time function, the default one that we've used and we saw in the previous webinar, and I'm either dividing it by 2 or doubling it, depending on which part type it is. Thing to remember is that walk time is derived from dividing the path length in pixels by the walk rate. We could easily change the path length by dragging our paths, or dragging my machine to a new position to give myself a longer path distance. If I wanted to change my walk rate, however, it's slightly different. If I go to Model, Options and Paths, we can see the walk rate is set as a 1, and we can go into this box and type in whatever value we wish. But that of course involves us directly interacting in the box. Walk rate is one of those areas in Witness that only evaluates at the beginning of the model run. There are several places in Witness where it is considered potentially dangerous to allow values to be changed whilst the model is running, and this is one of those. So in general, we would have to set this up at the beginning of our model run. However, there is a way around it, and it's worth sharing this with you because it could be quite useful, not only here for setting the walk rate in paths, but also in other aspects of witness. I'm going to go to user actions, model user actions, and in here I have a command, a SetInfo command, which is going to be used to change the walk rate from the current value of 1 to a value of 2. And again, I don't have to use a hard-coded number in here. This could be a value read into a variable, which is then interpreted within this command. Let me run it first of all. So if I click OK on here and press the Execute User Actions button, and then go back into Model, Options, Paths, we can see the walk rate is now 2. And if I run my model, you'll remember the times here were 8 and 32. And if I run the model on now, we can see the times are now changed. They've been halved because our walk rate is twice as fast as it previously was. So I can change my walk rate at any point in the model run if I wish to do so using the SetInfo command. SetInfo uses the witness library file or list file for its source of information. If I go to File, Save As, and rather than saving my model as a model file, I save it as a list file or a model library file, and click Save. Well, I've already got one, but I'll save it again. And then if I look in my Explorer, which is just off screen, I can see I have a library file or a list file. So I'll open that in Notepad, and this is a complete text listing of my witness model. It contains all the definition of elements, all the display information, and all the detail information, rules, cycle times, breakdowns, etc. I want to move down to find, and I happen to know where this is, so I'm just going to type in the word options to take me to where I want to get. And down here I come to the options, and we can see the indenting is in fact the way we navigate our way through this block of text. So I need to find myself at the base level to display, then I go to options, then I work down to find the information I want, the walk rate, and this is the thing I'm going to change. And then at the end of this process I need to extract myself, so I need to do end options and end display. And if I go back into the model user actions, you can see that command there. So we have a SetInfo is a function, so the arguments are contained in brackets. It is a string function, so we have quotation marks at each end, and it executes the command. It goes in to find the display part in the list file, which you don't have to save out incidentally. It will go and find it. We only displayed it out to show what was going on. The \n is effectively equivalent to a new line, and by using the \n symbol I can compress everything onto a single line of executable code. So it goes to the display part, then to options, then drops down to walk rate, sets it to the value I've chosen, and then extracts outward. So SetInfo command is very useful. We can do it to change things like cycle times, quantities of machines, a whole host of other things as well. So it is very powerful, but you have to be very careful to have the syntax right. If I was to miss that semicolon off, or make it a comma, or make it a colon, it will not execute correctly, so you have to be careful. But it does give us as modelers huge power. In this example, a model initialize actions, I have another SetInfo command to restore the walk rate back to 1. So if I were to begin my model and start it over again, and go take a look in model options paths, I can see my walk rate has been set back to 1. Okay, the next model I'm going to move on fairly quickly to, because we're about a quarter of an hour through and I want to leave some time for any questions later on, is I'm going to open the model pseudo-path travel time function. In this model I've got, and again I'll set it running, I've got 4 machines and parts are moving from one machine to the other in turn along pseudo-paths. The attribute that you can see displayed with times, if I slow it down a bit so you've got a right chance of seeing it, it's about as slow as I can get it. I'll go to step mode so we can see the attribute that has the time for each leg of the journey written onto it. I do timestamp my part when it arrives in the model so I can work out the total length of time it's spent in the system, which effectively is the sum of these 3 legs of travelling. But rather than use the built-in walk time function, which some people may be a little wary of because it's not something you can actually get into and see very easily, I've done my own homemade version. If I look at my machine, on actions on finish, I am going to calculate the journey time for the next leg using my function fn calc move time. Into that I'm going to pass 4 properties: the x coordinate of my first machine, and then the y coordinate of my first machine, then the x coordinate of my second machine, and the y coordinate of my second machine. In all of these witness machines on the screen I have exactly the same code. The only thing is different is the machine name. So a machine 4, my source machine will be M4 and my destination machine will be M3. From here my source machine is M3, my destination is M2. Because the calculation I'm going to do is the same no matter where I go, it makes sense to extract that information into a standard witness function. I'm passing 4 values across, and I therefore need to have 4 locations to put that information where it can be worked upon. So I'm passing the x1, y1, x2, y2 coordinates into this function. And I create some local variables. I bring them into existence at this point in the model. I use them only within this function, and when I leave this function those variables cease to exist. I then have a number of calculations I do, the end of which is the transfer time for the next leg of the operation, and that value is returned back into my machine, into here, where it is stored as the attribute journey time. The machine then pushes the part onward using the path, and because it's pseudo-paths, I go to Model, Options, Paths, the journey time is whatever is written on the attribute of the part. So it's calculated at each machine, will have a unique value, and that is then used for the travel time of the next leg. One thing that I can show you which is quite useful is the debugging facility which is available in Witness. So I've ticked the debugger box, I click OK, and now I'm going to set my model running, or step it forward, and when machine 1 completes cycling, it goes into actions on finish and it executes this code. And we can then take a look at what's going on inside this code. So I'm calculating the x distance from M1 to M4, and it doesn't matter to me whether it's a positive or negative number because I could be going left to right or right to left. What I need to know is the absolute distance in pixels that we've travelled. I can see that my machine M1, if I hover over the cursor and we look in the top window here, is around about 86 and 25, and we can see those are the values that have been passed across. If I look at machine M4, again the coordinates are around about 680-ish, 294, and we can see those are also being passed across. I can then step through here either by this button or by using the F8 key to step through, and it calculates, and we can see now the difference between those values. So between 88 and 688, not surprisingly 600, and the difference between my two y values is also calculated 264. In this case I'm going to convert that to meters because of my speed I know is in meters per second. or per minute. So I'm going to divide that pixels by my mapping factor, which in this case is 8. The mapping factor is set in model options coordinates. We'll go there briefly when I've finished through here. But that gives me a conversion from a distance in pixels to a distance in meters for both in x and y. I then apply Pythagoras' theorem to get the diagonal distance, and I convert it to time by dividing by my speed, which in this case was 5 meters per minute. I round the value down so I can display it on the screen without having a lot of digits shown as my parts progress through. And at the end of it, I have got my transfer time calculated, which is shown here as 16.39 time units. So if I press run one more time, there's my value, 16.39. So debugging, if you haven't seen it before, is really useful in stepping through blocks of code to see how effectively it's working. So I'll run my model again through the 3 machines with their individual travel times calculated through that function, and the sum aggregates to 31.55 minutes. If I stop my model and I move my machine a lot closer, and I can continue running on. And we can now see our revised travel time, once this is all passed through, is down to 19.95 minutes. So simply by moving my elements around, I can change my travel time. So hopefully there's something in there beyond just paths which will be of interest to you. Okay, 2 more models I want to show you quickly before I ask for any questions. The first one is office movement, and this is one of the standard models on the WITS installation. So you can go and look at this one. You can get at it through the go to view, make sure your start page is enabled, and then through sample models you can find it in here, office movement.mod. Close the start page. This model has got a number of paths, which is the white background, that are linked together to provide a network of routes for parts to travel through the model. Generally, parts have to travel more than one path to get to their destination. In the models we saw before with our operator moving along between machine 1 and machine 2, I always had a machine between adjacent paths. In this case, you can see probably we don't have that. We have paths butting up to paths. So the first parts arrive and they come along a pathway, which is path 001, and it ends at this point here. I then have another path, path 005, taking my parts on to their destination. Equally, there's a path here which links this first path down to a location at the end, and then finally another path. So if I need to link paths together, you cannot go into path display and link a path to a path. If I were to double click onto this path detail, we can see that the source is the office entrance, which is this buffer, and the destination is something called node 2. If I go to this path and look at the properties, that links node 2 to my office queue register. This path here links between node 1 and node 2, and then the path beyond links between node 1 and its destination. The node is a physical witness element which is just placed there as a placeholder. It can be a part, which is in this case, or it could be a buffer or a machine. So you can see here my paths module, as well as all my paths, I have a part called node 1, which is simply passive. It doesn't do anything, it's simply there to act as a bridging piece between my buffers. So by using these nodal and end elements, parts, buffers or machines, to act as nodes, then you can find a way of linking a succession of paths together without having to go through any intermediate physical elements, like a machine. So if you want to build a path, that's the way to do it. Final thing I'm going to show you is I'm going to open another copy of Witness, which is Witness 14, which is out very soon now. So you won't be able to do this, although the other models which I've shown you will be available for download shortly. Until you have Witness 14, you will not be able to open and run this one. But this is a paths model that we saw some time ago. I simply have put a kink into my long path that's walking from machine 1 to machine 2. Set the model running, and we can see our parts going along there. We can see our labour changes direction, so he's always travelling in the direction it's facing. And if I go to Model, Quick 3D, I'm going to build myself a 3D world. Very simple world here. I've got a checkerboard floor. I can change the floor, put carpeting on it to make it look better. I can build walls around it. I can put it inside a building. I can do pretty much everything I want, but this is the basic starting point. And if I run my model, you can see that the man is travelling, let's zoom in a bit, around the route. He is actually walking. We have leg movement and swinging arms. When the man gets onto the track between M1 and M2, let me just step forward, we can see he's actually walking with a part up in the air in his hands, and he's not swinging his arms. So it starts to make virtual reality a lot more lifelike than we've previously had. If I go to my path in 2D and I want to open my toolbar for paths, so I go to View, Toolbars, Paths. Having selected this path, I can go to the Information dialog, and this is a path I built up in the previous webinar, so you'll have seen this much so far. But what I'm now going to do is add some height in. So my person first of all goes straight, then he goes round a corner, and on the third segment I'm going to say he goes up 1 unit in height. It doesn't have to be a whole number, I can use decimals. Then round the top, and then coming down the other side, here I'll have him going back down a unit in height. If I click OK there, and I do a quick 3D, so if I run my model now, we can see that our person will now be going up in the air, over whatever obstruction is in the way, and back down. So again, we can add height into our paths. We can have walking people, and we can have people holding parts. So that's what's coming in Witness 14. There's a few more refinements to go in before it's fit for release to the public, but we're getting pretty close to being ready to go with that. Okay, I've talked for about half an hour, which is probably a little longer than I intended to, but if I could invite any questions if they haven't already been sent in. Alternatively, if you send them in, we will deal with them, answer them after the WebEx is complete. It's time to draw us to a close. Thank you for your attention. I hope you got something out of it. If there's any feedback you can give us afterwards to help us know how the presentation went, what you'd like to see different in terms of content and also execution, sound quality, image quality, etc., please feed that back to us and we'll try and make things better and better and better. Otherwise, thank you very much for your attention. I hope you have a good day, and I look forward to doing a WebEx again sometime in the relatively near future. Goodbye.